Good morning, Mr. Walber here, Section 8.4, Samples and Populations, the last section of Chapter 8. You can read basic idea what it says here. Population is an entire group of people or objects, where a sample is part of the population. Example, students at Springland Middle School is a population, where students in my fourth hour is a sample. Alright, a lot of what this is about is just basically reading data, figuring out what's good data, what's bad data, understand the difference between populations and samples, as I talked about last slide. It says here, an agency wants to know the opinions of county residents on the construction of a new road. The agency surveys 800 residents. Identify the population and the sample. Well, your population, in this case, is all residents. Obviously, they didn't survey all. So that's your sample. The sample is what they surveyed, and they surveyed 800 residents. So understand the difference between what this is here. Your population is everybody, and their sample size is what they surveyed. Like I said, a lot of what we're doing here is just trying to figure out what's good data and what's bad data. It says you want to estimate the number of students in a high school who ride the school bus. Which sample is the best? Well, 4 students in the hallway is not a good sample of who rides the bus. All students in marching band, well, that's just a select group of marching band students, so that's not a good answer. It says 50 seniors at random. Again, that's just seniors. You want a sample size of basic group of students. That doesn't make sense. Obviously, that leaves us with D, 100 students at random during lunch. Well, it's a random group, it's 100, and obviously they're picked out of the lunchroom, so that is your best example of a sample group of students. It says here you asked 75 randomly chosen students, so 75 were polled here, how many movies they watch each week. It says there's 1,200 students in the school. Predict the number of N students in the school who watch one movie a week, and is the prediction appropriate? Again, we're looking at data. Does it make sense with what is being asked? Obviously, here is our circle graph that we all are experts on now. One movie out of 75 people, 21 said one movie, 24 said 2 or more, 0 movies is 30. So, if we're asking 75 people, and there's 1,200 in the school, it says predict the number of N students. So, let's do A together here. We're going to go 21 out of 75, and we want to know what is that out of 1,200. Cross multiply, obviously, X would then equal 336 students. That's how you would find that. Obviously, by reading this circle graph, you all should be experts from doing the last section. B, is the prediction appropriate? Well, it says here that they were chosen randomly. Also, there were 75 people, so it's a decent group. Obviously, 1,200 is a big population of a student body, but 75 is a lot of people, and it was done randomly. So they ask, is the prediction appropriate? I would definitely say yes. I'm not going to write it all out. My explanation would be is our number is fairly high. It wasn't like they pulled 5 people or 10 people. 75 is a lot of people, and the second reason is it was done randomly, and that gives it a pretty accurate accuracy. Excuse me. So your practice problem here. You want to know the number of students in the classroom who do their homework right after school. You survey the first 5 students who arrive in the classroom. Answer A, population survey. B, what's the sample of the survey, and is this reasonable, and explain. That's due tomorrow, and look forward to seeing you. Have a great night, and where's R2-D2? Here's R2-D2. Bye-bye. Have a good night.